Hi everyone, I welcome you specially to this YouTube channel, the Merchant Construct-preneurs and Tutors. Talk about construction and engineering related topics. So today we'll look at how to calculate the design loads acting on the structure. In my last video, I talked about how loads are being transferred by different elements down to the foundation. So this is just like a continuation of it. So loads can be imposed loads, can be dead loads, can be wind loads. So how these loads are acting, so that's what we're going to calculate. So a brief explanation to refresh our memory of how loads have been transferred. Now, ever wondered how a building manages its weight? It's not magic but a clever design. Buildings transfer load like a relay race through a defined path. Now, if you remember a relay race, we'll be able to understand, have an idea of how loads have been transferred. So transferred from one element to another structural element to another. So from the roof down to the slab, from slab to the beams, to the beams to the columns, columns to foundation, depending on the number of high-rise buildings. Okay, so the weight starts at the top, that is the roof floors, and is passed down through the slabs, that is the floors, to beams. This is the horizontal support. Now the beams then transfer the load to columns. Columns are the vertical supports, which carries all the weight way down to the foundation. So this is just saying from the roof to the roof slab, to the slab, to the beams, to the columns. Column then takes it down to the foundation. Now the foundation collects all this weight and then distributes it safely to the ground. So this transfer of force ensures the building remains strong and stable. So that is it. So the reaction that the ground we absorb or we give must be more than what the building is giving to it. If not, there will be a problem. So let's look at this example. A composite floor consisting of 150mm thick reinforced concrete slab supported on steel beams spanning 5 meters and spaced at 3 meter centers is to be designed to carry an imposed load of 3.5 kN per meter square. Let the unit mass of the steel beams be 50 kg per meter run. Calculate the design loads on the typical internal beams shaded. So this is the shaded, this is the question, how is it shaded? So we'll take it bit by bit to understand how this thing works. So first and foremost, we are going to look at the parameters. We are going to list the parameters that was given and also what we intend to look for. I hope we are following. So if you get these things, if you pay very close attention to what I'm saying, you will understand how loads are being transferred and how to calculate it. So let's get started. Solution. Given in the question, we have reinforced concrete slab thickness 150mm, length of steel beams, we have it as 5 meters, distance of steel beams apart, we have it as 3 meters, slab imposed load QK is 3.5 kN per meter square, unit mass of steel beams 50 kg per meter run. So the parameters we have to calculate for the unit weight of the materials and also the design loads. Now we have two materials, we have reinforced concrete and we have steel beams. So how these loads are being transferred from one element to another. So we are going to take it step by step. So for the first one, A, unit weight of materials. Like I said, we have two different materials. We have reinforced concrete and we have steel. That's for the beams, reinforced concrete beams, and we have steel. So for the reinforced concrete, we have unit mass of reinforced concrete is 2,400 kg per meter cube. Then gravitational constant 10 meter per second square. So unit weight, formula for unit weight of reinforced concrete is unit mass multiplied by gravitational constant. So if you multiply that 2,400 multiplied by 10, we have the answer as 24 kilonewton per meter cube. So that is, we have calculated for unit weight of reinforced concrete as 24 kilonewton per meter cube. So we are looking at the second item or the second material. This is the steel beams. So the unit mass of steel beams given in the question is 50 kg per meter run. Gravitational constant, that is acceleration due to gravity, in other words, 10 meter per second square. Then unit weight of steel beams is still calculated as unit mass multiplied by gravitational constant. So multiplying 50 by 10, we have it as 500 Newton per meter run. So converting to kilonewton, so we have uniform units. So we have 0.5 kilonewton per meter run. So we are moving over to the next step. First, we have calculated for the unit weight. Now we are looking at calculating the loading. Now we have three elements. Slab loading is there, the reinforced concrete is there, concrete beam is there, and then the steel beam is also there. So I hope we are following. So for the slab loading, we have dead load and imposed load. We are looking at loading 1.4 QK plus 1.6 and 1.4 GK plus 1.6 QK. So we have it as slab load is self weight of the slab, as thickness and unit weight of concrete. We have it as 3.6 kilonewton per meter square. Then for the slab imposed load QK given in the question, 3.5 kilonewton per meter square. So ultimate load, as I said, 1.4 GK plus 1.6 QK. Manipulating it, we have it as 10.64 kilonewton per meter square. I hope we got this. Like I said, in the question we are given the imposed load of slab. So slab was transferring its load to the beam, the reinforced concrete beam. Now the reinforced concrete beam is also transferring its load to the steel beams. Are you seeing it? So for the beam loading, we have beam dead load as the self weight, and the self weight we already calculated it as 0.5 kilonewton per meter run. So the ultimate load, it doesn't have any imposed load, is 1.4 GK. So calculating it, you have this. Now for the design load, you now want to know the total load that is acting on it. You know, the first one we were talking about individually. Slab has its own load, beam has its own load. Now we are going to take everything in entirety. So each of the internal beams supports a uniformly distributed load from the slab, that is at a distance from the midpoint from a span towards both sides of the beam. What I mean by whatever I have said is, look at this illustration, this drawing here. You see the pattern, that the pattern is not going the same direction. Look at the label for beam, look at the label for slab. Now look at the slab. I labeled it as 1, 2 between beam A and B. Then between beam B and C, you have 3 and 4. So halfway, 2 transfers to B, 3 transfers to B. So that is how it is. When you have a slab, half goes to the beam on each ways. So now the design load on beam will have the slab load plus self weight of the beam. So the just addition of what we have there from the loading. Addition of what we have from the loading of the beam and also from the loading of the slab. So thank you very much for this content. I hope you got value for it. For more educative content on construction and structural engineering, kindly comment and subscribe to this channel, the Merchant Construct-preneurs and Tutors. Thank you very much.